Okay, so this next exercise, we're going to have a look at exercise 2F, which is about families of straight lines. So there's really two types of families of straight lines. The first is where there is the constant y-intercept. So it would be of the form y is equal to mx plus 2, where m is the perimeter. So all the lines will pass through the point 0, 2, because that's the y-intercept, but the gradient will change. And you can see in this graph here how there's this family of lines that's all passing per point 0, 2, but with different gradients, such as, so you've got a half here, you've got a gradient of 1 here, gradient of 3, so you can see it's a lot steeper, and negative over here. Okay, so that's one form of a gradient of a straight line. One form of a family of lines. The other family of lines is lines with a constant gradient. So the gradient always remains the same. So for example, it could have a gradient of 2, but the y-intercept is the variable that can change. Okay, so for example, you could have y is equal to 2x plus 1, y is equal to 2x plus 4, y is equal to 2x minus 3. And that will help you identify that the gradient is always remaining 2, as you can see in this graph here, but the y-intercept is changing for each line, but they still hold that commonality of the same gradient. Okay, so there are two kinds of lines you can have. So a few different types of questions can come from this kind of information. So for the example 1 we have here is find the value of m if the line y equals mx plus 4 passes through the point 3, 2. So maybe you could have a go at doing this. You'd use substitution, so you could pause the video here. I'll go through it now. So all you need to do is substitute this point, which lies on the line, into this equation so that you can find the unknown, the m there. So in this case, 2, substituting it, because 2 is equal to y, is equal to, m is our unknown, x in this case is 3, minus 4. Okay, so rearranging that, you'd add 4 to the other side, plus 4, so 6 is equal to 3m, and get the variable onto the left-hand side. M is equal to 6 divided by 3, which is equal to 2. So you know that the gradient, or m, is equal to, for this line, is equal to 2. Alright. So moving on to a bit of a longer question here. So the family of lines has an equation of y is equal to mx plus 4. So the constant is the 4 here, which means the gradient is the thing that can change this family of lines. So it'll all be going through the same point, but just have a different gradient. So that would line up with the first example here, just with a different y-intercept. Okay, find the value of the x-intercept in terms of m. So when you're finding the x-intercept, x int, a here, where y equals 0. So substitute that in, 0 is equal to mx plus 4. Now we're trying to find the x-intercepts in terms of m. So we need to get x by itself. So minus 4, negative 4 is equal to mx. Therefore x is equal to negative 4 over m. So that's finding the x-intercept in terms of m. You don't need to know what m is, because you're just finding it in terms of m. So part B asks you, for which values of m is the x-intercept greater than 4? Okay, so we know that the x-intercept from our previous question is negative 4 over m. And we want to know when that x-intercept, for what values of m, is it greater than, this x-intercept greater than 4. So all you need to do is get m by itself. So this is bit where work on inequalities from chapter 1 comes in handy. So you need to get m off the bottom, multiply by a positive, so the sign doesn't change there. So negative 4 is greater than 4m. And then you need to divide by negative 4, which will change the inequality sign. So divide by negative 4, so we got, sorry, my mistake, you would divide by regular 4 because you want to get m by itself. So the sign wouldn't change. So negative 1 equal to or less than m, and then you just need to put m on the left hand side,